Hello, I'm Brian Goldstein. Welcome to the January Energy Lunch. I'm the Resource Conservation Manager of Jefferson County. I'm also the presentation coordinator for the Energy Lunches, which have been going on for about 3 years now. And it's really wonderful to see some new faces in the crowd here, as well as the old familiar faces and the young familiar faces. The Energy Lunch is all about creating a forum for us to discuss local energy issues. And where else can we all come together and really talk about taking action in local energy, which most of us believe in. And there's a lot of energy projects going on today in the county. We had in our December meeting, we actually had a breakout session where 7 of us discussed the energy action projects that we are involved with, and that we've taken the recording from that and transcribed it. So you'll all get to see that. So it's a great summary of some of the energy projects, and maybe it'll be a project that you'll be interested in, and you could contact the leader at that point. Let's see. All talks are recorded. Thank you, Gary and Kitty, and placed on the porttownsendjournal.com site. So in our last survey, a quarter of you said you have actually gone out to the site to see maybe a talk that you missed. So all of our talks are archived there. And one other thing of business, if you want to get on the local 2020 Energy Action Group listserv, which many of us are on, there's a lot of good energy ideas that get sent around on that listserv. You can just let Ellen know, and she'll sign you up for that, and we'll make sure you get on that. It's a couple emails a week, and it's things about our energy projects that are going on in the county. I want to thank our sponsors. The Jefferson County Chamber of Commerce and Local 2020 help promote this event and sponsor us, as well as the Washington State University Energy, the extension. Didn't have that written down. And then we have 4 paying sponsors, and I want to thank Alaska Power and Telephone, Huber's Inn, thank you, Letitia, Power Trip Energy, and Sunshine Propane. And next week, the port will become one of our partners as well. So I'd like to welcome them in advance. Now, I wanted to let Cindy Jane come up and take a minute and discuss what she's doing in the local 2020 group.
Thanks, Brian. My name is Cindy Jane. I'm relatively new to this area, so I've met a few of you, but I haven't had the chance to yet. It's been exciting to see all that's going on in climate change and energy action in this community. I got involved with Local 2020 early on, and now I'm heading up the Climate Action Group, which is sort of complementary to the Energy Action Group, which many of you are involved in. And what we're doing is leveraging the climate action plan that the county and city have done, and really looking for a couple projects that we can take on as volunteers for the community to implement, in terms of implementing the greenhouse gas reductions and also the adaptation side of the climate action plan. So I just wanted to put that out to you. There's lots of great people here with wonderful education ideas. If you're interested in participating, come talk to me. I'd love to get your contact info. And if you don't want to join the group but are interested in just sharing some of your ideas and your thoughts as to the projects that would be appropriate for us to tackle, I'd love to hear that too. Thank you. Small world.
Cindy and I actually worked together when I lived over in Redmond. We worked together with the Northwest Earth Institute steering committee together, so it's a small world. I'd like to say that for February, we have a very special talk. Barney Burke, our PUD commissioner, and a representative from PSE will be here to talk about our upcoming transition of our electric grid from PSE to the PUD, which is happening on April 1. So it'll be great to have you come there next month. Thank you. So, Norm Olson is here from Iowa State University. He knows farmers and he knows farm energy systems. And he's had a number of years in the Iowa Energy Center at ISU, and he's addressed the energy needs of a wide variety of farms and farmers throughout the state there. And so please join me in welcoming Norm as our key speaker.
Obviously, I'm not going to be a farm expert on energy for this area of the nation, but I think there's some similarities that can carry over. I mean, almost every product you grow is going to need some nutrients to take off, and especially in this area, you're going to have some biomass resource. I heard talk about willow trees, fast-growing willow trees and poplars and things like that. So you're going to have the opportunity to do some of these things with biomass. We classify all this stuff as biomass. In Iowa, it's corn stalks and bean straw, soybean straw, out-of-condition hay, obsolete seed corn, wood waste from tree trimmings when the tornadoes roll through, or just to keep things out of the power lines. We have tree trimming. There's just a lot of resources we have out there. We'll talk a little bit about energy efficiency, which should apply region-wide, a little bit about waste energy, and quite a bit about one fuel in particular that I think really ties together local production of fuels, your ability to produce local fuels, and environmental issues, climate change issues. So I think the fuel I'll be talking about there will tie those two things together pretty well. Well, generally what I say, energy efficiency first. You know, I work in the areas of alternative fuels, but energy efficiency comes first. It just makes sense. It's probably one of the surest bets you have, one of the most cost-effective things you can do, and it applies no matter where you live. Now, your climate doesn't have the real extremes we have. In Iowa, energy in a house consumes a lot of your dollars. Here, my sister just put air conditioning in a couple years ago. You must have had a little hot spell that they just couldn't take it anymore it must have been 85 for two weeks or something. You know, we go over 110 in the summers at times, and we go to 30 below zero in the winters. So we have those extremes, and in a way it makes energy efficiency easier to do because you're spending more on energy in buildings and stuff like that. So I always say energy efficiency first. Agree entirely with Graham on that. It's just a logical first step and a very good economic development engine. You're going to have people doing energy audits. You're going to have people installing things like energy efficient heating systems, windows, insulation, all kinds of things. It's just great for any community to do that, and you're doing a lot of good things for the environment. Just the numbers that I try and sell in the state of Iowa, and we're just embarking on this. We've done a lot of it in the past, but we really have not made it just a concerted effort. Let's do it in the biggest way we possibly could think of doing it. So I threw a target number out there. If you could save 20% of the energy in your home or business, and we've done that a lot of times. That's not a really out of the ballpark number. The savings in Iowa would be about $1.5 billion in energy savings, and it would cost you about $9 billion to install all that. If you just roughly use half of that as labor and half as materials, you know, just for ballpark numbers, that's about 60,000 person years of jobs at $70,000 per job. That's bigger than anything we do in the state in terms of economic development. We were all excited about a new ammonia, anhydrous ammonia fertilizer plant going into southwest Iowa that's going to create 150 jobs. You're talking about a lot of jobs. I don't care if it's Washington, Iowa, or wherever you're starting. So I agree entirely with Graham on this. Energy efficiency first, even though that's not my primary area. Wind and solar resource assessments. If you don't have wind, you shouldn't mess around with wind turbines, obviously. Iowa has a situation, and one of the reasons it's has the third most amount of wind turbines installed in the nation, and the most per capita because we don't have a lot of people. We're behind Texas and California in terms of total wind installation. It's because we have a situation called Buffalo Ridge. It's where the winds just come howling in from Canada, Alberta clippers, so to speak, and we have a lot of wind energy, but we did 6 years of wind studies, and we found out that basically because we're a summer peaking utility company or utility grid there, because we have air conditioning going in August, that's right when the wind energy is the least available in the state. So it's not really a very good match between how we consume energy in the state. Solar is much better because since air conditioning is driving that peak load, and solar generally is out when you're hot, it's a pretty good match. So we think solar is going to make big inroads, but wind gets the subsidies, bigger subsidies right now. But solar costs are coming down, so solar PV and especially solar thermal energy we think are going to make big inroads in the future. But just some of the things we did, resource assessments are crucial. We had 12 sites around the state, and for 6 years we measured wind and solar data. So we know pretty much what happened for that 10-year time period. I can't remember the gentleman that said, well, what happens if the rain shuts down? You know, if you have substantial climate change, obviously none of these numbers make any sense, and we are in a pretty short time frame. So these numbers could change, but for the time we've been alive, this is kind of what's going to happen. Not to say it won't change. The facility I work at is called Beacon Biomass Energy Conversion Facility, and our goals there are to provide credible first-hand information on renewable bio-based fuels and chemicals. So it's the biorefinery model. And I said earlier, oil companies know how to make money, and they have oil refineries. And they make everything from pharmaceutical grade chemicals, specialty chemicals, and then plastics, things like that, and then fuels, and then road tar. And they use every drop of that barrel of petroleum. And we probably want to use that same business model if we're going to talk about a biorefinery to decrease our dependence on imported petroleum. So first-hand information, we're real close to Missouri, the show me state. I think everybody likes to be shown. They don't want to experiment on their own dollar. And we're a state entity, so we're willing to do some experiments and see if things work and help people make better decisions when they finally are ready to go. We're doing research, testing, demonstration, education, and training on these technologies that are becoming cost effective. And almost always focus on the chemicals first. They're higher value, lower volume. You're not going to get into food versus fuel issues when you do those types of things, and you're probably going to make a little more money. We kind of bridge that gap at this facility I work at between the laboratory, bench scale test tube stuff, and the real commercial world. And oftentimes that's known as Death Valley because companies go in there with a good idea and they don't come out economically. It's tough to start up a new industry, a new technology. And rural economic development, we think that's real important, and a very close tie to energy when we go through it. We have 6 main technologies we're talking about developing there, and we mentioned some of these this morning. Anaerobic digestion, just bacteria getting together as groups to break down organic material. They generally turn it into chemicals first, usually organic acids, a mixture of organic acids, and then it goes into usually into methane, the main component of natural gas. And with methane, you can do a whole host of things. You can make that into a chemical factory. That's what they're doing in the Middle East right now. In areas where they have a lot of natural gas and it's expensive to ship overseas, they're turning into liquid chemicals and fuels. And so a lot of technology is already out there. If you have biomass, can turn it into methane, you can do a host of things with that. Thermal gasification, kind of the same type of thing. Sasol, there's a company in South Africa called SASOL, and they were boycotted at one point in time and weren't being shipped petroleum because of some of the policies they had in that country. And so they had a coal resource, and they went with coal gasification. That just turns coal into carbon monoxide and hydrogen, and then they've developed technologies, and a lot of it comes from the Germans in World War II, where you can make a host, again, of liquid fuels and chemicals from that carbon monoxide and hydrogen. I call them Lego building blocks for engineers, chemical engineers and chemists. They can put those together in so many ways and make so many things, even alcohols like ethanol. So that's another way of doing it. Pyrolysis, that's another heat-based means of turning plant materials into chemicals and fuels. And it ends up making a product that looks like bio-crude oil. It looks dark oil. If you haven't changed your engine oil for too long, it starts looking a little like that, and it takes a lot of refining. Then we have biodiesel, renewable diesel. Biodiesel is generally made from fats, oils, and grease, and there's not enough fats, oils, and grease currently in the world to make a big dent in the diesel fuel we consume. Again, one gentleman or someone asked about algae today, and I really hope algae works because that would be one that could change how that works. They'll produce enough oil, and if they really get algae going, according to the promise they're publishing, that you could make a big dent in the diesel fuel that we do consume. Fermentation or ethanol. On the way up we were talking about butanol. Butanol is actually a much better fuel than ethanol, but it's more expensive to make right now. And there's 2 companies in the big lawsuit battle suing each other about a technology, a way to produce butanol. And you really just start with sugars. I mean, corn to starch, corn starch to sugars to ethanol or alcohols. And that's the way you do it right now. One interesting thing about that is ethanol is just one step away from ethylene. Ethylene is the #1 chemical in terms of volume in the world, and it's used to make plastic. So polyethylene. And it's really easy to turn ethanol into ethylene. And in Brazil, they're doing that now. And what a way to take carbon dioxide out of the air, put it in the plant, turn it into ethylene or plastic, and that carbon dioxide is locked up for a long time in that plastic part. The last technology we talk about is supercritical fluids, and you've all learned in high school science that oil deposits were formed over millions of years when plant materials were buried under high pressure and temperature conditions. Not really high temperature, but fairly high pressure. It turns out that with high pressure water, we can turn plant materials into oils in a matter of seconds. In fact, it happens so quickly that we can't control it. It's really a control issue how we do that. And that's a more experimental technology. We've been able to turn cellulose into ethylene and propylene glycol, which are really nice targets because they're high value and fairly high volume chemicals used for like antifreeze. And so that one's more of a research-based project for us. And just the Iowa biorefinery. That model has a lot of appeal. And again, we've been talking, there's a lot of similarities here. Some of the small towns in Washington are dying just like the small towns in Iowa. And the reason in Iowa generally is because a couple reasons. You know, Walmarts make everything, and so the small stores can't compete in the town. And then the farms are getting big. Pretty soon one farmer is going to farm all of Iowa. And there's no farm kids and there's no people living there. And to me, it's a terrible situation. But if you do something like this, the reason it's hard to make a living on a small farm. But if you create more value before you send it out of town, like in the biorefinery concept, then you have a chance to make a living on a smaller farm. So that's one of the goals I like to see, because I came from a smaller town in Iowa, and I like that lifestyle. But you could have a lot of really good jobs at a factory like this. And what's the best thing about it, though, is when you're done processing, you take the nutrients back to the soil. When we ship corn to feed the happy cattle in California, you guys probably don't see that commercial. There's a kind of grates on our nerves in Iowa, because they show this advertising, and there's a cow, you know, in Iowa walking around the cold and really, you know, grim looking and stuff like that. And then you go to the cow in California, and it's just walking on this nice green pasture and happy. And happy cows make happy milk and come from California. Well, where do they get the corn to feed those cows? The trick is, because of subsidies, that works. But if you really did it logically, you'd feed the animals in Iowa that produce the milk and ship the milk, and then take the manure back to the soils and build the soil quality and have a sustainable thing. Instead, you end up with a bunch of manure in California that who knows what to do with it. So not the best model. Subsidies don't always help everybody and make the most sense. But I think this slide helps a lot in terms of why this probably will work if we get better to chemistry. You can buy all the corn stalks you want in Iowa for $60 a ton, delivered to a pretty short distance. And if you believe that oil, petroleum, came from plant materials, you can kind of see where we're going with this. Corn at 3 cents a pound, oil at what per barrel now? Somewhere between $75 and $100 a barrel? Somewhere in there. Let's just say it's, you know, somewhere around 26 cents a pound for petroleum. So almost 8 times higher per pound than corn. Now, if you're a business person and your main cost of doing business is raw materials, you can see where you could end up in pretty good shape there, even at today's petroleum prices. The reason it doesn't work is there's oxygen in corn. And in hydrocarbon fuels, there's no oxygen. It's carbon and hydrogen. There are chemicals that have oxygen in them. So if you pick your chemicals right and do a better job in your chemistry, in your manufacturing plants, you have a chance to compete. That's why I usually say, let's target chemicals first and leave fuels for another issue there. So you can see why there's some hope that that'll work. And then you go, you know, forward to the past, back to the future type thing. Prior to the 1940s, a lot of chemicals were made from plant materials. People like Henry Ford and George Washington Carver, who was an Iowa State graduate, said that everything you need for everyday life could come from the farm. And, you know, in the meantime, we use petroleum because we're just not quite sharp enough to do it yet. But I think there's a lot of potential there and a lot of logic in what they were looking at back then. Ag looks good. I think that's rapeseed. That might be out west area. That's not Iowa. But I think any place where you have agriculture, that's a good system. One thing I want to talk about here that ties both fuels and energy and the environment together is anhydrous ammonia is a fuel. The chemical formula is NH3. It's without question the cheapest way to deliver nitrogen for fertilizer. It's all over the state of Iowa. There's 800 retail ammonia outlets for fertilizer outlets in the state. One right in the middle of town I live in on the way to work, there's a big anhydrous, it's called a bullet tank. It's a 16,000 gallon tank sitting there right in town and right next to the soccer complex. But not only is it a good way to carry nitrogen, it's an excellent way to carry hydrogen. There's approximately 1.5 times more hydrogen in a gallon of anhydrous ammonia than there is in a 10,000 pound gallon of hydrogen. And there's still much more hydrogen in a gallon of liquid anhydrous ammonia than there is in a gallon of liquid hydrogen. Now that doesn't make sense when you say that, but hydrogen doesn't like to get next to each other. Even at a very low energy state, they're still repelling each other. And so ammonia is just a very, very cheap way to deliver hydrogen. And I'll probably mention this one twice because ammonia actually burns cleaner than hydrogen. And that's another one that if you're interested in the environment, that's a big issue. And this has been proven at Toyota. There's no measurable pollutants in an engine run in a Toyota lab coming out of the tailpipe. And they had that verified by a third party as well. With hydrogen, you'll get some what's called NOx emissions, just because nitrogen in the air, and anytime you're in a heated environment of the type that we have in an engine, a combustion engine that is, not a fuel cell, you're going to form some NOx emissions. And the way we clean up NOx emissions at coal plants and out of diesel engines is inject a little ammonia or ammonia compound in with that, and it breaks the NOx into nitrogen, which is N2, which is 78% of the air we're breathing right now is nitrogen, and water. So you can see where ammonia has its own cleanup technology built in, and it's actually cleaner burning than hydrogen. It's much cheaper in terms of delivery infrastructure too. It's much more energy efficient. It takes less money or less energy to make ammonia than it does to compress the hydrogen to 10,000 psi. So it's an energy winner, it's an environmental winner, and it's a cost winner if you're going to have to store and transport it. The example I gave a presentation on ammonia fuel at the National Hydrogen Association meeting, the last one they had, where they gave up on hydrogen. Arnold Schwarzenegger was a keynote speaker, and I kind of got a kick out of him anyway. But it was down there in Southern California where the event was taking place. Yeah.
Quick question: hydrogen ammonia can work in fuel cells? Repeat the question.
Well, he's asking if ammonia can work in a fuel cell. And in a PEM fuel cell, you have to crack it into hydrogen first and really clean it up because ammonia is not good for a proton exchange membrane fuel cell. But you can manufacture direct ammonia fuel cells that are fairly low cost that can run directly on ammonia. And solid oxide fuel cells run great on ammonia. Solid oxide fuels run on ammonia right now, but they're expensive and very high temperature for that. So the engine might be the best route to go right now. But anyway, the cost of a 5-gallon, 5,000 psi hydrogen storage tank with my educational discount was $5,000. I can buy a 5-gallon propane tank, propane is so similar to ammonia in terms of how it's stored and transported. You just don't use brass or copper alloys because ammonia will corrode that. So you just use steel instead of copper alloys. For about $60. And so the cost is so much different in terms of storing and transporting hydrogen. The energy density is so much lower with hydrogen that, you've heard of a chicken's the other white meat. We've called ammonia the other hydrogen. It's the same thing, just a cheap way to deliver it. There's a lot of existing infrastructure out there for ammonia. You can make it from wind, solar, biomass, nukes, coal, hydro. It doesn't matter what you have. You can make ammonia from that. It's mainly you make the hydrogen either by cracking water or take it from a source like coal or natural gas. It is in the top 3 chemicals delivered worldwide. It's all over the place. It's all around you. We had our one conference 2 years ago in Portland, and they've got a huge ammonia terminal right there outside of Portland that they bring the ammonia in. We've got them all over Iowa, of course, and it's cost competitive, and I'll show you a chart on that a little later. Environmentally friendly. End-use flexibility. It's kind of like converting an engine to propane. You can't just dump it in there and expect it to go. You're going to have a different tank and a different fuel delivery system. But you can use it in spark ignition, diesel engines, fuel cells, gas turbines, and it's a proven acceptable safety record. As you can imagine, if anybody's familiar with anhydrous ammonia, it is a dangerous chemical. It's a fairly strong base, and so like you can get acid burns, you can get base burns. Lye, is dangerous when you use it wrong. But we did 2 studies. We found one from Netherlands, and we commissioned one from a group in Oklahoma that's known worldwide for doing safety studies for the petroleum industry and the fertilizer industry, one of the few that does safety studies for both, and they compared propane, gasoline, and ammonia, and the conclusion was it'd be safer than propane in transportation applications, safer than gasoline close up to an accident, and more dangerous than gasoline far away from an accident. And there's a bunch of details on that, but we're going to stick on time. If I get long, give me the sign real quick. I'm going to try and go short. It's just a great performer. Freedom Card targets established by the federal government for hydrogen and ammonia met those back in 2004 when we first started working with ammonia to meet the hydrogen goals. There's just some energy density stuff, what I won't look at. This cost kind of ties natural gas to ammonia cost, and this is from TFI, Verticon, a big, huge ammonia producer. They've made these charts up, and I added this right-hand column here. But for natural gas prices down in the $3 to $4 range, you can produce ammonia, and just read to that side, for those dollars per ton, if you can see on the left-hand side. And that corresponds to dollars per million BTU. You can't do dollars per gallon with ethanol, really, or gasoline, because they have different energy content per gallon, so you do it per energy, how much energy you're buying for that dollar. You can see ammonia with the $3 natural gas can be produced in the $6 per million BTU range, and gasoline at $3.50 a gallon is $30 a million BTU. So you can be cost competitive when you're making it from natural gas. Now right now, again, because of who knows exactly why, but low cost ammonia imports caused almost over half the capacity of ammonia production in the United States to shut down a few years ago. And when you get rid of competition, and there's a chance for prices to rise, prices usually rise. And so ammonia is much higher than this, what it should be right now. The price margins used to be about $20 to $50 a ton, and now they're closer to $500 a ton profit margin for people like the Koch brothers and people that control what's left of the industry in the United States who are making money like crazy right now on anhydrous ammonia. But these are the costs that it should be. Just some of the costs associated with transporting it in. Locally produced is a thing I really like, no matter what it is, to the greatest extent possible. And energy and food are two pretty important things you like to produce locally. China is the biggest producer of anhydrous ammonia right now, and they make it mainly with coal. Again, NH3 is one of the top 3 chemical shipped worldwide. It's all over the place. There's pipelines from the Gulf of Mexico up through Minnesota and throughout the Midwest, just because that's where the majority of the use is. Delivered for corn. You couldn't grow corn like you do now. Here's some of the ways it's stored and delivered. This is represented that kind of tank that we have in town, right in the community I live in, and how they refill with the hose and stuff. Nurse tanks, that would represent, with the 23 on there, probably a 20 to 30,000 ton storage tank. And they're stored at atmospheric pressure, chilled ammonia. It'll go liquid at minus 28 degrees Fahrenheit. So in Iowa, there'd be times when your ammonia tank wouldn't be pressurized in your vehicle because we hit minus 28, and so there's not much pressure left there, so you'd have to pump it out like you do gasoline. Normally it operates in the range of about 150 pounds per square inch, so not very high pressure. To liquefy it. This just shows the pipeline that we're talking about going from the Gulf of Mexico up there. It's real important for economies to be able to ship fuels and products as a liquid. It's a very cheap way to deliver product. And ethanol has a problem with pipelines, and I won't go into that either, but over 800 retail ammonia outlets. Arnold was bragging during his speech down there that California had 36 hydrogen refueling stations. And I said, well, we have 800. Well, I didn't say anything, obviously. I said it to myself. 800 hydrogen refueling stations in Iowa. They're not exactly fuel stations yet, but they are retail outlets for ammonia. There's an interesting link for me here with natural gas. Now, if you want to get serious about climate change, and I think people are getting more serious about it, but you could convert the methane or the natural gas that comes out of the ground at the wellhead into ammonia. You could take the carbon dioxide that's formed when you make ammonia, pump it down underground, and extend the life of the well. They're doing that all over the place right now. To extend the life of oil wells and gas wells, they pump carbon dioxide underground, They're always looking for more carbon dioxide. So let's extend it. So now you've got a carbon-free fuel here produced at the wellhead, and you're extending the life of that natural gas field, and you've got that zero carbon fuel. You can ship by a pipeline, for the same diameter pipeline, you can ship 1.5 times more energy in the form of ammonia than you can in natural gas, and you can use ammonia in every application natural gas can be used. And of course, you don't have to make natural gas to ammonia remotely because it's already ammonia. We cooked some hot dogs and marshmallows over an ammonia flame in the Bunsen burner in a lab a couple of years ago, and again, it's just hydrogen. But ammonia won't explode very easily. That's one of the reasons it's safer than propane, and yet by itself it's very difficult to get it to explode. And so what we do on the way to the engine is crack part of it in hydrogen, so now you've got a mixture of hydrogen and ammonia, and it takes very little energy to crack it, by the way, back in the hydrogen. And then it burns pretty well. Of course, hydrogen really is a great burning fuel. And there's the natural gas pipeline infrastructure, and it's just going to increase. So I steal this from the hydrogen people. They say, well, let's put hydrogen in the natural gas pipelines. Well, there's a lot of problems associated with that. There's embrittlement issues, and the amount you can ship via pipeline is really small in terms of energy compared to natural gas. But if they say it, if you want to think big, you could do that. And you could, that would be a long ways off. Well, a refueling station could look something like this. Underground storage, you could store this chilled, so there's no pressurization. Ammonia is also a great refrigerant. It's an amazing chemical. It can do all kinds of things. So say you shot a high-powered rifle in there and punctured that tank. Well, it would leak out, depending on how high up you shot it, at the static head pressure of the liquid in there, and it would go down and sit as a liquid. As it evaporates, it cools itself, so it slows the rate of evaporation down. In general, if you have a big ammonia leak, you'll freeze the ground around it, and it'll go very slowly. Any gas that did go out is much lighter than air, so you'd go out and go up the pipe, and you'd burn it off. It's way safer than gasoline. You can't get it to blow up in this liquid state. When it does evaporate, it evaporates in a gas that's lighter than air, and you can just combust it as it goes out the top. So I think safety would not be a big issue. There's a bunch of stuff on the safety, and I won't go into too much detail, but there's a lot of studies out there, and plus just common sense. I'm not sure. The way we transport ammonia in Iowa is a farmer will pull up 2 big 500-gallon tanks behind his pickup and tear off down the road. Not much of a permit going on there. And I'm saying, would you do that with 2 500-gallon tanks of gasoline necessarily and feel safe about it? And to tell you the truth, I don't feel real safe with either one of them, but that's the way it's done. But again, with these things right in the middle of town for years, and ammonia can kill a person. There's just no doubt about it. But it's going to be safer than propane and as safe as gasoline in transportation fuel applications. Generally, the onboard storage for the tank would be about 250 psi rated tank, operated generally at 150 pounds per square inch. Anybody heard of this stuff? I probably have my name on a federal website someplace because I look up ways to make methamphetamine. Just because you make it with ammonia. Ammonia is a component used to make methamphetamine. It really isn't made from ammonia. Ammonia helps in the process. So I looked it up. The chemical formula for the cold medicine that everybody gets is that formula, C10H15NO. Formula for methamphetamine is C10H15N. Ammonia just strips the oxygen off there, and that's all it does. And there's a new method that they're using in Iowa now, it's shake and bake. You don't use ammonia, you do something else, and you blow yourself up a different way. It's not a good thing, but you can't make methamphetamine without that. Oklahoma started it, I believe, and a lot of groups are following it. You can't buy that cold medicine more than one package at a time, and it's computer tracked now, and if you do, you get a visit from somebody. Why are you needing that much cold medicine? So that's the secret of that. And there's some other things that ammonia gets blamed for, but really, NOx emissions, ammonia is used to clean up NOx emissions. If you used all ammonia fuel, you wouldn't have much NOx out there. Here's how it's put in place in Iowa. It's knifed in. That's supposed to represent a steel blade going in the ground. It's just injected through open holes underground in the open atmosphere. I'll walk behind the applicator every year outside the cornfield outside my office just to prove a point, I guess. But and that's pulled behind the tractor and injected in with that type of system. If you haven't seen that before. There's all the applications. It's real flexible. Since you can make it from any primary energy source and modify any engine to run on it, that's a great thing. What's really exciting to me, there's a person or a company called Sturman Industries, and it's run by a person named Eddie Sturman. I won't tell that story anyway. I'll skip something else later. But he was born in Israel, and he was about 7 years old in 1948. You know what happened in Israel in 1948? Huh? Who said that? Yes. Israel became a state in 1948, and the next day, or maybe that day, they were attacked by all surrounding countries, and he was there during that time, and it, of course, influenced his outlook on life. But he's developed this new engine, and basically it's, count on yourself to help yourself, is his philosophy. He's developed an engine that can run on just any fuel. It's a completely revolutionary engine design. It's in his test lab right now. He's produced all kinds of commercial product. He was like NASA Engineer of the Year at one point in his career. And he's 73, about 73 now, somewhere in that ballpark. And he has that engine, he took him about an hour to get it running on ammonia in compression mode, like a diesel engine. We've never been able to do that, but his engine's different than anything we have. And he's really promoting this and has a lot of good contacts on that. But future could look something like this: wind and biomass, solar and biomass, clean coal or nukes, doesn't matter what you call any of that stuff. Taking nitrogen from the atmosphere, combine it with hydrogen from any source to make ammonia for stationary power, fertilizer, and transportation. You have a carbon-free society that you can probably afford in the not-too-distant future, unless oil goes to zero. To me, there's still problems with petroleum, but I won't go into those too much. Get to the summary here, I think we're about... Unfortunately, I have two summaries. So basically what I'm saying here is ammonia has a lot of good characteristics associated with fuels, and you can make it just about any place you choose to make it, which I like a lot. It's currently made from coal and natural gas primarily, but it can be produced from your wind, your solar, your tidal, ocean thermal energy. Any of those can be used in any engine type. Direct ammonia fuel cells are being developed. NH3 is not a greenhouse gas. It's a prevalent naturally occurring chemical. It's not a known carcinogen. I mean, you have it. You're having ammonia in your body right now. Almost every living organism has it in there. It's a natural part of the cycle out there. And so, really, it's probably one of the least problematic fuels you could have out there. Biodiesel is pretty good. Any fuel has risk. Any fuel has risk. I've asked this question to thousands of people now. Has anybody ever heard of a terrorist using anhydrous ammonia to kill people? No, you haven't. You're thinking of Oklahoma City, right? That's ammonium nitrate. The Timothy McVeigh thing was ammonium nitrate, which is a really explosive, high explosive chemical. Ammonium itself, it's not high enough power for killing people, so they don't use it. The father of modern chemical warfare, Fritz Haber, also invented ammonia. And he ended up killing himself after World War I, in part because he felt bad about gassing people with all kinds of toxic chemicals, but he didn't use ammonia because it just didn't do the job well enough. So it's dangerous. And I said that 3 times, and I'm not going to say it's not, but it's less dangerous than the other alternatives we have for the most part. And it's just a great way to deliver hydrogen. So you think hydrogen's a great fuel, here's the most cost-effective hydrogen you can get. So that's the presentation, pretty much on time. And if they have time for questions.
Yeah, absolutely. So we have time for questions now, and we'll come bring you the microphone.
Thanks. Great presentation.
Thank you.
So Norm, we met earlier. I'm Barney Burke from the PUD. I wondered if you could tell us if this is a great future. What's the biggest obstacle to deploying this technology in the way you envision? What's the biggest thing you need to overcome?
I say just introducing anything new against an established industry like the oil industry, I mean, you could literally get killed trying to move this forward. And certainly financially, you could get put in dire straits. It's not going to displace petroleum in the near future, just because they have a lot of political clout and because they're probably more cost effective right now, although it's close. I mean, you can see what the price of anhydrous ammonia should be based on natural gas prices in this country. And as more ammonia production is built, you'll see the price of ammonia come down back to more close to where it should be. So it's just going to be a battle of who's going to make money from it. I mean, whoever has the most money wins. And until there's a chance for people to make money on this, it'll be a small demonstration type fuel. And I mean, ethanol started off back in the 70s called a still on the hill. You know, the little farmers had ethanol plants and they kind of made a run at it, and then they stopped and started and stopped and started. And then it became a big industry, and now it's being wiped out to a certain extent, or a good chance that it might be. So it's a tough battle. It's what it has going for it, though, is you might be able to produce ammonia in a little coffee pot style ammonia production unit. That's the goal of one of the presenters at one of our conferences there. It's kind of like the mini nuke thing in Back to the Future movies. But so the biggest thing is you've got tough competition. If you think the oil industry would just sit back and watch something displace it, that's probably one of the toughest industries to go against you could come up to. So I think that's the number one challenge. But we have to prove more too. We have to have more demonstrations out there. You should be able to see one going down in your local community, you know, to see what you think about it. So you got to get the demonstrations going. We haven't done a really good job of that yet. It's mainly in the laboratory. So I'd say those things. Number one, there's a lot of development work left to be done in the long term, competing against petroleum. I wouldn't pick them if I had to, but I mean, that's kind of my job, so I have to.
Well, converting a gas engine to propane is relatively simple. Is it basically the same technology, or is it a little more complex for
It's a little more complex because you're going to crack some of the ammonia into hydrogen to have a mix. And what we found is you crack a certain percentage, say like 20% of ammonia into hydrogen, so you're burning the 80-20 mix, then it burns somewhat like propane, and if you crack another percentage, it burns more like natural gas. So, but other than that cracker, it's to crack it into hydrogen. That's the main component difference, because they're both pressurized tanks, about the same pressure range. They both go liquid at a certain pressure. So there's a lot of similarities to that, and you can make it burn look almost like propane when you crack it that way. So one component more.
And you were talking about corn as a possible material to increase energy production. And my question to you is, if it were to go that way, would people be careful enough to grow organic corn, or what do you see there in the fields?
Not in Iowa. I think the top thing they're interested in is protecting the soil. They are interested in that because they understand that's part of their livelihood. Organic is a tougher one for them to meet those criteria and still keep the prices competitive. So most of the big farmers in Iowa aren't going to do that, that type of thing. And I wouldn't propose corn as a good long-term fuel production feedstock anyway. You know, we're kind of saying maybe corn stalks, probably pretty good because of the way we farm there nowadays. And I talked about that earlier too. I don't think it actually helps the soil quality if you take some corn stalks off. Now it doesn't sound right at first, but combined with other techniques, it actually helps the soil. So corn stalks are something that kind of would like to be taken off on flat land, which we have a lot of. And so I'd say if you're making any fuels, that would be the choice. In Iowa, it would be corn stalks.
I wanted to follow up about the corn, and is there any transition from corn to sorghum production in Iowa for ethanol? Is that something that you've seen at all?
How did you come up with sorghum?
Well, I know the Chinese are using sorghum for ethanol production. It has a much higher efficiency. I didn't know if that's something that...
Yeah, that's a good question. We've done some research on that, and we said, you know, Brazil grows sugar cane to make low-cost ethanol, and California likes sugar cane ethanol better than corn ethanol. It's just another reason we don't like the Californians. They're always bashing us. And I was told if I would have put California instead of Oregon up there, I'd been run out of town here rapidly. But sweet sorghum is the closest thing we can grow to sugarcane in Iowa, and it's a really good grower. It's less intensive on energy inputs, so more drought tolerant, makes more tons of stuff per acre per dollar that you spend on that acre, and so it's a great crop. But we've gone through that thing before, you know. If you don't have a market for it when you grow it, you're in problem, and nobody's going to build a processing plant until they're sure somebody can grow it and turn it in. So it's a catch-22 thing there, but it's a great crop, I think. Better than corn in several aspects. But it's just tough to, again, get anything new going is just really difficult, even though it's a good thing.
Most of the farms in Jefferson County are small, under 100 acres, I would think. Can you give an example of using ammonia to convert into energy on a small farm application? Something we can visualize?
Yeah, that'd be a real weakness for me here because I don't know your farm. And I was trying to get some data on that as to what exactly happens here. And I just found out today one dairy farm left. Of course, manure is a great source of that type of thing. And then I was also told you don't have a lot of waste coming off the farm. Everything you produce basically is shipped out as good product or stays there and doesn't cause any accumulation problems. So it'll be more difficult to make it from there. The biomass I see here is if there's a wood waste or stuff like that would be, to me, a better potential. And then any solar type energy or ocean thermal. I don't know what the ocean thermal is off the coast here. In California, they say it looks pretty good because of the temperature difference between the surface waters and the subsurface. But so I don't have a lot of good advice because I just don't know. I don't know your farms that well. But if you're going to make anything from biomass, if you have any biomass whatsoever, you know, ammonia would be one thing that could do double duty and help in nutrients, because crops do grow better. I don't know if you're greenhouse crops or anything like that, and nitrogen fertilizer generally helps a lot of crops, not all of them, to go that way. But so I'm pretty weak on that one. Sorry about that.
Could you give me a real quick breakdown on how to convert wind, solar, more electrical-based energy into ammonia, how easy that is, or if there's some downsides, and how that would be gone about?
Yeah, from wind and solar, you're going to be cracking water into hydrogen and oxygen. You know, the junior high science experiment, somebody's always cracking, using electricity through water and making a gas, and that's the route, electrolysis of water with those types of technologies. So it's going to be water dependent, but it takes about a gallon of water to make a gallon of ammonia. The hydrogen balance is such that, so it's not a real intensive. Almost any fuel is going to take a lot of water to make, and especially now that you're seeing.
What kind of electrical input for that gallon?
They're about 70-80% efficient, electrolyzers, in converting the electrical energy to hydrogen energy. And then you've got a next step of combining the hydrogen with the nitrogen from the atmosphere. And so that takes that, there's an energy penalty there as well. But those energy penalties always show up in cost. You know, so you can kind of tell by the cost what energy penalty you're paying. And it's not a real complex. You can buy skid-mounted smaller scale ammonia production units right now, which I really like, again, because it's a more distributed process. A company out of the Netherlands is marketing those. And they're the ones that said that they someday, somebody asked them, how small can you go? And he says, someday, that type of arrangement. So.
When ammonia is injected into the soil behind your tractor, what's the chemistry? Why doesn't it just escape into the atmosphere?
It loves water. And when it's cool, it'll stay with the water. And so generally you're applying this in the fall or spring when there's moisture in the soil. You know, I'm wondering what's going to happen this year because our subsoil moisture is so low in Iowa. It's just unbelievable we even produced corn because there was so little rain. But it'll stick with the water. So any place there's water, you're injecting it, and there's usually water in the soil. It attracts water. That's why it's harmful to you in a way, because in your eyes and in your respiratory tract, it's going to stick with the water, and then you'll get a base burn because of that, because it's attracted to the water. It's a high affinity for the water. But that's how it stays in. It minds the water, and then it pretty much stays there. Kind of like your household cleaner.
Hi, Norm. My question is about compressed natural gas, which is actually almost an ideal fuel, very low carbon emission. Wouldn't compressed natural gas be the competition? I know hydrogen, like you said, is not a good idea, but compressed natural gas is really pretty well developed.
Yeah, T. Boone Pickens is pushing that one real hard, and it's going to be dependent on how well fracking works to see how low-cost natural gas stays for how long. But natural gas is a great fuel, but it still has at least 50% of the emissions of coal. I mean, so it's not like you're carbon-free here, even with natural gas. So it's a good fuel, I think. The tanks are generally about 3,200 psi, so they're pretty high-pressure tanks. Southwest Research Institute, which is one of the premier engine fuel testing labs in the world, and they're down in San Antonio, Texas, showed us a video of a hydrogen car exploding. They intentionally did it with a 5,000 psi tank. There's a lot of energy in a 3,000 or 5,000 pound tank, and about the only thing you could see from the video is a windshield going up real fast. Everything else was just, it's not without its risk. But it's a good fuel. It's just like any fuel we talk about. They all have their risk, but I think natural gas is a good fuel. But it's a pressurized gas. It's not going to be a liquid. And there's always some energy density issues with that. And there's cost issues associated with the tanks that you have to deliver that in. Now some people are saying let's go liquid with it, but minus 278 degrees Fahrenheit, that's a cold tank on board. But there's actually some people talking about that, and it gets expensive. The high pressure and low temperature tanks cost a lot of money. But it's not bad. I wouldn't knock natural gas, especially if it's U.S. produced.
All right. Yep. Time for one more question.
Since we don't really have any ammonia available to us out here easily, I was wondering if there's places like back where you are where they do have ammonia that they don't have the infrastructure for the passenger cars, but say, for example, a fleet is successfully using this because they've got a place they can go back and refuel. Is anyone doing this as far as transportation fuels or farm equipment for tractors and so forth?
Yeah, that's a great idea. Those are the best demonstrations. You've named two of them right there. It should be the farm where they're already handling it and the fleet vehicles where they're round trip. The Clinton Foundation has kind of joined on this effort. Bill Clinton's formed a group that deals specifically with climate change and fuels. And they're trying to get a fleet demonstration going. Real hard. Believe it or not, he says he doesn't have a lot of money, the guy that represents the Clinton Foundation on the energy side, but that's what we're working on, is we need demonstrations like that. Just like biodiesel started with bus fleets, city bus fleets and things like that. So that's a really good comment. No. I mean, that's where we're weak. That's one of the things I mentioned that we need to get going. That's one of the reasons that until you people can see this someplace and get running comments for a year or two, that you don't make much progress if they have demonstrations, I don't think.
All right. Please join me in thanking Norm for talking today.